We get started, I want to do a temperature check. I'm going to throw a post in here and you can actually, let's just respond with a GIF. Okay. How are we feeling post module 9? Right. So we did an introduction to React. We started talking about some APIs. So okay, Dragosh is waking up from I think it's a coma, right? I think that's the whole thing for Walking Dead. I don't remember. It's been years since I've seen the first season. Omar is inserting himself into history as an awkward bearded man. Okay. But you're not dead, right? So that's good. So let's see how everyone else is feeling before we jump into databases and SQL. Oh, is that the guy's name? Harold? Okay. Yeah, I don't know. I've seen the meme before, but no clue. Okay, Joseph is bearing with it, right? And I think I've talked about this, but I definitely felt similar when I started learning React, right? So, full confession, I didn't finish my boot camp. I wish I would have, right? Just time necessities, unfortunately, I wasn't able to. And I didn't get that good hands-on experience with React until later when I started doing a freelance job and they're like, hey, do you know React? I'm like, barely. So I pretty much learned it on the job. And I will say it's a lot easier to learn something when you're not having to worry about getting grilled and, you're having to build people for something that you're not 100% sure on. So all that to say, like learning React is a lot in the beginning. But as always, it's just a practice, right? So my suggestion for you would be if you have something in your head, right? You're like, this would be an interesting application to make, and don't go overboard, right? Everyone's like, oh, I want to make a Twitter clone. Okay, that's way too, like, no one should be doing that for their first project, right? Their first fun project. But think about something where I may have shared it, I may not have. I made like a screen time calculator. So you could like put in, okay, how many hours are you on your phone every day? And then it would not only break down how many hours per week, but per month, per year, right? And it was like, oh my gosh, I'm on my phone way too much. But it's just a simple React application, right? Nothing that we haven't done. It was using state. You press the plus or minus button to adjust the hours, right? And just things like that. It's not overly complex, but it gave me an opportunity to, well, I know what I want to build, and I had to sit down and chart out what I wanted to build, and I made the application. Um, there's also another one. I know I'm not sharing my screen, but give me 1 second, I'll show you. This one was in Angular, but it was the same concept of I just want to build something and learn the framework, right? So I have this application, it's called a kaiju calculator, right? So you would go through and you would look at, okay, well, let's look at Godzilla, right? So I want to figure out, well, how many Godzillas would fit into a certain length, or so I'd say like, okay, how many feet, if I had 20 feet, it would be 0.12 Godzillas, right? And it's like, okay, why do you need to know that? I don't know. But I just thought it was fun, right? So then I could be like, how many miles if I had 1 mile? Well, that would be 32.19 Godzillas. So again, it's nothing super crazy, but I just went through and I was like, okay, I want to build a fun application where I got a bunch of different heights and lengths of monsters from different franchises, and I just made a simple application, right? I don't know if any of you are familiar with Homestar Runner, but I had something similar to that. So, going through, let's see, I'll pull this up. So what I did is I took a bunch of Homestar Runner quotes and I made a lorem ipsum generator, right? Because I was building a lot of like I was scaffolding out a bunch of projects and I didn't always know what I wanted my text. So I was like, okay, well, I'll just generate my own lorem ipsum, right? So what I did is I figured out, okay, I would just, calculate if I want so many paragraphs, so many sentences. I just have this big file and I would parse out this file and generate lorem ipsum. So again, my point in all of this is just saying you're not going to learn something without practicing. And this course that you're taking, it is obviously meant to help teach you, but it cannot be the end all be all, and I know Veronica can attest to this, is like, this is meant to give you that foundation of what to learn, but you still have to build and practice. So just my encouragement to you is, just think of something simple, right? Don't think about necessarily the APIs yet. Don't think about, how to save stuff in a database yet. We're working on that. But just find something that you're like, I just want to build a basic application. You're not trying to share it with anyone. Because by the time that you start problem solving and building all of these things that you're like, man, I just need more time. Well, this is going to be that time, right? This is going to be the way to really allow these concepts and ideas to cement in. So again, just wanted to show you some stuff, just be like, hey, like, again, you don't have to be out there trying to build a brand new application that no one has ever done and trying to get users, right? The goal is, well, I have a problem, how do I solve it? And learning and taking these things that we've learned to do that. I constantly go back, well, not so much now, but I was constantly going back to my boot camp material to be like, how do I do this thing? Well, I would go to the lesson, look at the example, and I would use it, right? This material that you're getting here is meant to be referenced over and over again. So keeping that in mind, we are going to be talking about databases and SQL today. Like Juan said, you can hear SQL, SQL. I just go for SQL. I'm not going to make a huge fight about it. I'm not going to correct people, right? But you're going to hear me say SQL, which stands for Structured Query Language. So in today's lesson, we are going to learn about the role of databases in web development and cover basic SQL operations like data querying and manipulation. So by the end of this lesson, which is meant to be a very introduction approach, it should be a little bit lighter. We're going to understand the basics of database systems and why they're important. And then we're going to perform some simple SQL queries to retrieve and manipulate data. So before I go to the next slide, in the chat, how many of you have done any kind of database querying at all? Like maybe through Python? Again, you'd still be using something like SQL, but who here has done any kind of database work at all? I'm always surprised that I feel like there's usually a few people each cohort who maybe they haven't touched any front-end development, but they've done database querying. Okay, looks like Omar has. Acer has. Yep, I figured there'd be a few people. Looks like some other people are typing as well. Okay, awesome. So hopefully this isn't brand new for you. Joseph, you were saying just some basic select. I mean, yeah, that's it may be basic, but that's pretty foundational with SQL. So it's I will say I don't use SQL very often now. I'm trying to remember the actual name for it. In Azure, you'll have your querying tools, and I don't remember what they call theirs, but I'll do that all the time, right? Is I'll just be like, hey, I want to find a particular user with this user ID, and then from there, I might write some queries to be like, okay, who submitted their tax return from this date and this date, who completed their tax return, who didn't complete it, so that kind of querying I do on a regular basis, but it's not complex, right? It's just selecting here, maybe a group by, right? So querying doesn't have to be complex, but it is something that is used in any major application. Like you have to be able to retrieve data from a database. Okay, so no warm-up questions today. That's kind of why I wanted to get our brains thinking a little bit before jumping in. So what is a database? All right, so we see here in this image, well, doesn't really explain a whole lot, right? Until we actually dive in and figure out what it is. So a database is just a collection of data, right? And it should be in an organized manner. for easy retrieval. Obviously, that's whoever is in charge of the database. That's their job to make sure that's the case, right? But in an ideal world, a database has a collection of data that's organized for easy retrieval. So this database gives us the ability to either get, retrieve, store, update information, right? You may hear some differing opinions on whether you should actually delete data from a database. That is a constant conversation, an ethics conversation, even at times. Um, but that being said, a database doesn't have to be huge, right? It could just be something very simple where you have a handful of users and you just want to know, has the user, like, you store their password and whether they're authenticated, stuff like that. And maybe that's it, right? There's nothing else outside of that database. Um, Now, of course, where this information is stored, right? Maybe you have a local database where you have it on a flash drive, or maybe it's an actual database stored on a server farm, right? There's not a hard rule on how a database should look, not to mention a handful of different places you can have a database, right? You can have Firestore. We're going to learn about Supabase. There's a handful of places you can do it. It's not necessarily this is the only way you should handle storing data. So with our web applications, we need to be able to interact with the database to store and retrieve data, right? And again, it's going to be different on how we do that. Every application is going to be a little different. So based on the application, that's going to determine what kind of information we need to store, right? So like I was just talking about before, maybe you have an application where you just want to make sure a user is authenticated and log in before they can view, like, maybe it's for a school, right? And it's displaying news updates for parents of students. And there's nothing that the parents can necessarily edit or change, but they just don't want anybody to be able to come on and view those updates, right? Or in this example, talking about an e-commerce website, we want to store product details. We want to store customer details, order details. There's a lot in that situation that we would want to store, access, modify. So that's where we need a database management system. Okay, so we need something to be able to mediate between the user, whether it's an administrator or a client, and the database, right? Especially, we don't necessarily want clients just to be able to access anything in a database. We need to have roles. We need to have proper authentication and mediation to make sure that this database is secure. So typically, we have two kinds of databases. We have relational and non-relational. So relational, as we see here on the left, it's the idea of tabular or table-based data, right? So each column and row in the table has to have a one-to-one correspondence. We'll get into that a little bit. It just means that it's going to be organized in a table. So let's look at an example of a relational database. So pull something up here in Google, right? So maybe you have a table here about ratings, and this movie ID is going to be tied into a movie table, right? And then that ID is tied into this table called tags, right? Whereas here in ratings, you have a user ID. So again, it's a one-to-one. It just goes from one table to the other. They're all related. Pretty straightforward just in regards to how the data is structured. But non-relational databases, which is we may hear called NoSQL, which, fun fact, doesn't mean that there's no SQL at all. We'll get into that. But this allows a little bit more flexibility and scalability, right? So if I was to go in here and say NoSQL example database, you can see here there's a lot of variation in how things can be tied together. Same thing here, which if this image would load for me, you pay so much for high-speed internet and it doesn't always work. Yeah, so I mean, it kind of depends, right? You can have a lot of variation here. You can have a graph database, you can have a key value database, a document database. This is what actually my company uses. We have a document database. So yeah, it doesn't have to be your traditional just one-to-one. which again, we haven't quite got there yet. So let's look at how this is broken down. So relational databases, everything's going to be stored in a table with a row and a column. Okay. So each table is going to be what you'd consider an entity, right? And think of it like you'd have customers, products, or orders. So you're not going to have a table where you would have customers, products, and orders in the same table, right? Each table or each entity needs its own specific purpose. So keeping that in mind, we'll see here in this example, we have students, student courses, and courses, right? So the table here on the left deals with students and is tied to the student ID, right? So we have an ID here on the left, and then in the student courses, we see the student ID, where each ID is correlating to that student. Whereas here on the right, we have courses, and each course has an ID, which here in the student courses table is tied to that same ID. So if we looked here, we would see student ID 1 has 3 courses that they're enrolled in: SQL Server, ASP.NET, MVC, and MongoDB, right? Whereas student ID 2, who we know is Mary by looking here, they are enrolled in Java and PHP. And then Tyne here is enrolled in Mongo and PHP. Okay. So again, each entity has its own specific role, and you really want to keep them separate, right? So that whole meme that you may or may not be familiar with is, you got my chocolate in your peanut butter, you got your peanut butter in my chocolate, whatever, right? The whole Reese's peanut butter cup thing. You don't have that here. Each is going to be separated. And then here, it is in essence combined, but that data is being related to separate entities, right? So this table here would be meaningless without these other entities, okay? So we would call this a SQL database because 9 times out of 10, we're going to use what's called SQL, which again is structured query language, as the interface for querying and manipulating data. So I don't think we've talked about it in this course, but this is a good interview question. If you hear the word interface, how would you define that? I've been asked this question numerous times in my career, so I'm curious if anyone has heard that phrase and you would know how to define that. And if you don't, that's totally fine. You can say no, but I think it's actually worth talking about here. A user facing something. Yeah, let's see what Joseph's typing here. An interface is like the API or wall between 2 applications. So when you get into actual programming languages, an interface, the easiest way I would say to define it would be a contract. And what I mean by that is, if anyone here has worked with C# or Java, not necessarily Python, but then you get into like TypeScript, you may see, and I'll show an example here, is C# interface, right? So here we have an interface called iNameable, okay? So it's saying that this object should only have one property. It's a name and it's a string, okay? This one here, iRaisable, it's an event and it's called event handler. If you get into TypeScript, which is JavaScript with types, you might see something like this, where the type would be animal and it would have one property called name and string. So the reason I say that is an interface, which type interface, they're very similar, but not the same thing. It's a contract because it's saying if I add this interface to an object, it can only have what's inside of this interface. It's a contract saying, hey, I'm agreeing that if I utilize this, I need to do this. So the reason I say that is with SQL, what we're saying is it's not necessarily the inner workings of that database, but we're saying, hey, we want to use this interface to get this data. So by putting this language in here, we have to follow the contractual obligations to be able to get this data. So that's where you have to understand too, if you're using a particular variation of SQL, you have to follow that syntax, right? So with SQL, you may have what's called Postgres, right? You may have transact SQL. There's one called GraphQL, right? This is a different kind of querying language. So it's really important to understand which interface you're using, and also understanding that by utilizing an interface, which is, again, an agreement, a contract between two parties saying, if this qualifies, give me this. So you have to be very particular in your legalese, your language, to be able to get that data. Right. So again, that's where I say I've heard this question numerous times throughout the past few years of how would you define an interface? And it's really just a contract, right, between two parties to either control the transmission or receipt of data, or the way that maybe data is being rendered. Okay. Little tip there to keep in your back pocket, because again, you may hear that in an interview. So a query, though, is, again, this is just a bit of code that either is going to request data from a database, it may change data, it may want to delete data, which would fall into that changing, right? So as I was talking about before, there's a handful of different SQL systems that you can use. You may see MySQL or MySQL, Postgres. I don't typically hear people actually say PostgreSQL or PostgreSQL. Yeah, it's PostgreSQL. Like most people just honestly say Postgres, and it's pretty understandable. Oracle, right? So Oracle is developed by Oracle. They named their own database. And then you just have basic SQL Server, right? So typically what you'd see in my experience is Postgres or MySQL or MySQL. It just kind of depends on the project you're working on. But 9 times out of 10, the querying syntax is actually going to be pretty similar. So let's talk about relational databases, right? So there's any decision you make when it comes to databases, languages, frameworks, there's always going to be an advantage and a disadvantage. So when it comes to advantages, it's really, really easy, in my opinion, to, as it's worded here, enforce data integrity, right? So you can make sure that as you are correlating things, so we see here, there's a table for customer and a table for order, right? You can link this up incredibly well, right? So you can make sure that your consistency in data, relationships between keys and tables, it's easy to enforce that. Now, if you don't know what you're doing, obviously your work's cut out for you. But as you become more experienced with databases and you start setting this up, it's really your work. It's hard to argue against this if you are trying to have a one-to-one relationship, right? So again, just that data integrity, it's very easy to maintain. And also, again, it uses SQL, it uses SQL, right? So it's something where if you learn basic SQL syntax, I mean, you can work with a lot of databases, right? There's always going to be some variations between the different versions, but you learn one, it's going to be easy to learn others. And then scalability as well. You can see, smaller relational databases and startups, and then you can see it in enterprise, right? So it's very easy to scale. So you're not going to have to be completely rethinking your database structure if overnight you get 10,000 users, right? So you could think, okay, well, we have an influx of users, we need to start collecting new data. That's fine. You just, okay, my user ID here can be tied to all the other entities. Not a huge deal. And there's a lot of good security tools for SQL because, again, it's established, right? So 9 times out of 10, you're not going to have to rethink or reinvent the wheel when it comes to database security. Now, It can be hard because if you have to make changes to a database schema, which we haven't talked about yet, but a schema it's kind of like an interface for your database entity. If you have to modify those schemas, it can take a lot of time, and you actually may have to put your like you have to have downtime for your server to make sure that as you're making those changes, it doesn't break anything downstream, right? So because relational databases are so tightly knit and in a good way, if you make a change, there could be downstream effects that you weren't predicting. You may have to take your server down to get those resolved. Um, Again, just because it's very structured, if you have anything that's not as structured, like a document, an image, JSON data, it can be a little bit harder to work with, right? And then with costs, I mean, really with anything, there's always going to be costs. But if you need like enterprise grade solutions like Oracle or SQL Server, it's just going to cost a lot more. But I wouldn't let that one dissuade you from doing a relational database just because at this point, it's probably going to be very unlikely that you would need anything of that level. But these two things here in regards to how structured the data is, it can be a bit of a challenge when you're dealing with things that are maybe not as structured. Okay. So before we get into actual SQL, right? So you can see here, we're going to start getting into some actual operations. How are we feeling about that? Like, do we have any questions about what was brought up so far? Or, how are we feeling? I know we haven't got our hands dirty yet, but just the concept of dealing with databases and having the information structured out in individual tables. Okay. Awesome. Love to hear it. Okay, so SQL. So IBM back in the 70s, they're the ones who really started getting the ball rolling, right, with this structured query language. And again, if you think about it, no matter, I'm trying to think of a good way to put it. So someone has to set the standard somewhere, right? So you think about when it comes to any form of technology, there's always going to be competing ways to try to solve a problem, right? But eventually someone will solve that problem and everyone else kind of jumps on board. You think about like USB chargers, right? Where, for the longest time you'd have USB-A, USB-C, or USB-B, then micro, and there's all these different versions. And now, iPhone had the lightning cable, right? And now everyone's finally getting onto USB-C. So whoever developed USB-C, it caught on, and now everyone else is doing it, and I'm all happy for that, right? I don't want to have 5 different chargers at my house. But the point is, someone's going to find a way to standardize something. So keep that in mind, just as you're thinking about things, and just being like, you know what, like someone's got to reinvent the wheel at some point to a certain degree. Maybe it'll be you. It'll never be me. I know that. But it's just always interesting. Everything we do, someone had to be like, hey, this is an idea, and everyone else ran with it. So SQL really has become like the standard for interacting with relational database management systems. So what we have here is a basic like syntax of our commands, okay? So first we have what's called a DDL, or a data definition language. So this is what's going to define the structure of the databases, right? So you might see create, alter, drop. So create being create, making one, alter meaning changing, drop meaning, well, we're going to get rid of this table. But then you'll have a DML, which is manipulation language. So, select being get me something, insert meaning creating, update meaning update, and then delete meaning delete, right? No point in having syntax and phrases here if they're not clear in what they do. which is what I really appreciate about SQL is there's no weirdness or ambiguity about what's happening here. So and then you have your DCL, which is data control language. I'll admit I don't really deal with this very often, but it does allow access to data within the database, right? So you could grant or revoke access or privileges to certain systems, users, etc. So again, SQL, the main foundation is something that you're going to see in a lot of different systems, whether it's Postgres, MySQL, SQLite, Oracle, etc. So again, whoever at the team at IBM that developed this, like, we're running 50 years after this and people are still using it, right? So that's kind of crazy to think about. Same thing with like HTML and JavaScript, like whoever developed JavaScript in the beginning, I can't remember his name offhand. I know everyone likes to joke was like, oh, it was only made in 12 days. Yeah, I mean, not as it sits now. We're talking about years and years and years of modifications. But yeah, it was something where it's like literally the majority of the internet runs on JavaScript, and a single person really helps set the tone for that. So absolutely crazy. So let's look at our example here. Okay, so we're going to run some examples. So on the left, we're going to see a console SQL client that is connected to a pre-created database. Okay, so in here, and this is something I'd love to see you guys working on as well. We can execute these queries and see what's inside of that database. Okay. So if you are currently here and you want to return to the command prompt, you can just hit Q and it will reset. Okay. So let's go ahead and create a query. So again, we're not creating a database, right? We're just accessing the data. So we are going to use excuse me. We're going to use the commands and the syntax to just retrieve some data. So even though it is copy and pasting here, I do recommend that you type this out, right? Let's get familiar. Let's get our fingers working. I know it's late in the day. So our first request, we're going to start with the select, right? So this is what we're saying. Hey, we just want to retrieve some data from the database. We're not trying to create. We're not trying to modify or delete. We just want to say select. And then we're going to do star. Okay, so star is just saying everything. Okay, so all the fields in that table. I don't want a specific column. I want everything. And then we're going to say from. Okay, so that's going to say wherever I'm specifying after this, this is where that data should be unloaded from. And then limit. So I'm going to say from actor, that table. And then limit is saying, you could retrieve everything, right? But I'm just trying to limit this to 10 pieces of data. Okay. All right. Select. Oops. Okay. Oh, yeah. That's what I get for not having the semicolon. Select. After why are you? Oh, it's still thinking I've got the Q there. Okay. SQL. There we go. Okay. So we see here, we've retrieved this data from a database. Okay. So we have 10 IDs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting set of actors, right? Can't say I've ever heard of Nick Wahlberg or Christian Gable. I think we can all tell these aren't real actors, at least as far as I know. Oh no, let's look, right? So Christian Gable. Yeah, I don't think it's a real actor. So point is, we're saying we want to select everything from the actor table, but we want to limit it to 10, right? So what if I did select star from actor, everything? Oh, wow, right? So you can see here, if you leave off that limit, it's just going to keep returning, right? A lot of people in here. So I'm going to hit Q now, which does return, it exits out of that, that query. right? So something to keep in mind here in the syntax conventions. So for readability, it's recommended that SQL commands be written in uppercase letters. That way, as you're writing it, or if someone wants to reference it, they know anything in capital uppercase words should be a SQL command. Okay. But let's try something different. So let's do select star from actor. Okay. It is case insensitive, right? At least in this context. But think about it this way. If you look at these two instances, it's a lot easier to know what you're doing when the actual like data is lowercase and the SQL syntax is uppercase. Okay. Now, it may be case insensitive for the most part, but it's not typo insensitive, right? Like anything, you can't just type something and the computer's like, oh, they said actors, not actor, but I'm still going to give them actor, right? No, it's literally just going to say, you gave me actors, right? So if I press up and try to change that, it has no idea. It's like relation actors does not exist. So you have to be careful with how you're typing that. Okay. So something to consider as well down here below says output may vary because relational databases do not guarantee order without the use of additional operators that are used for sorting. Okay. So in this instance, it is returning it by the actor ID, which is great. But based on how it's being organized, you may get things out of order, right? So just be aware. In this instance, we're getting everything in order based on ID, but based on that table, we may not get that. Okay. Something else I'm sure you noticed up here, right, is I forgot that semicolon. I knew I needed it, but I forgot to hit it. And because of that, it still wanted to go down, right? So it was saying, hey, the query wasn't done. So if you do not, I forgot how to actually clear this one out. So if you do not add that semicolon, it's going to think that the request is continuing. Okay. So I could do let's do, there we go. So I'll put semicolon there. So I'll do select star from actor, right? So I actually put each line of that query, or, I put different parts of the query on different lines, and it's still a valid query. You may actually see that. You may see people go select star from actor limit 5. That's a valid way to write a query because you want it organized like that. The semicolon is what's going to say, hey, this is the end of the query. This is also why when you start dealing with JavaScript and SQL in other languages at the same time, JavaScript, for the most part, is one of the most forgiving when it comes to semicolons. Other frameworks are not. Other languages are not. That's why I'm always going to vote, just use the semicolon. 9 times out of 10, the team you're going to work on is going to be like, just add a semicolon. So it's just easier to get in the habit of doing it now, rather than assuming like, oh yeah, I don't have to add it on, and then you forget to add a semicolon in a SQL query and it doesn't work, right? So how are we? What do we think about this, right? I mean, it's a very simple example, but what are we thinking? Like, is this on track with what you've done before? If it's new for you, what are your thoughts? Okay, Joseph's giving me a thumbs up. So far, so good. Definitely better than React. Well, sorry to break it to you. We're going to incorporate this into React. So, but I'm glad that you're feeling good about it. All right. So knowledge check. Come on. Okay. I do this in teacher mode and all right. Well, looks like we've got the answer already, right? So Which SQL operator is used to specify the number of rows to be returned in a query result from a Postgres database? So as we see here, it's limit, right? So based on that, there's going to be different ways to limit things, but again, it's always going to be based on rows, right? So you think about how we did our API response with our last module is if you only want a few instances of like Bob's Burgers characters, right? Let's see if I still have that in my hopscotch. No, I don't have that query from before. Oh yeah, I have this here, right? So remember with the Zelda API, we did a limit of 2, right? In essence, this is a similar thing, right? It's querying a database, and we're saying, hey, I want to limit my objects, the data inside of this data array to be 2. I could change this to 7, and now I have 7, right? So limit's important. We may not want everything, right? If you think about if there's a database with thousands of pieces of data within that database, but you only need a few, well, don't query the whole thing, right? That it's not just a matter of how long that querying might take. It actually could be a money thing, right? So there's going to be reasons why you'd want to have multiple, or I guess having that limit on there. Okay, good. It's not gonna, we don't have another one. Okay, so let's talk about CRUD operations. So I had mentioned this a few weeks prior to making a CRUD app, right? It doesn't mean that you're making an application that's cruddy or less than desirable, right? CRUD is an acronym, and it's something that stands for, it's a SQL operation, create, read, update, and delete. And it's not necessarily in the order that you would be using them, but I would say argue you'd probably see read, create, update, delete, but you're not going to have RCUD, right? CRUD just makes a lot more sense. So basic overview, our create is when we want to add new data to the database. So with that SQL syntax, we're going to have insert into, okay? So what we're seeing here is insert into. We want to specify what table or entity we're inserting that data into. And then within parentheses, we're adding this data right down here. Sorry, I was kind of jumping ahead. So insert into table name, and then we specify where it's going to be added. And then the values here are how we're inserting it. Okay, so insert into, and then we have the values syntax here. Okay. Whereas read, that's just our way of we want to get data, right? So keep in mind, just because we see create C, we're not seeing that same letter here. It's just, again, just the principles of create, read, update, delete. So with read, that's going to be select, which we've already seen, right? So when we read or select data, we're not modifying it. We're not creating anything. We're not updating anything. We're not deleting it. We just want to retrieve that data. So here we see select column 1 and column 2 from table name where condition. Okay. And I know we have some examples here, but I'll try to make some time. We can make some more examples if we get to that point. Update is where we can modify existing data. So in this example, we see update the table, right? And we're going to set column 1 to equal value 1, column 2 to equal value 2, etc. And then we may have a condition, right? Doesn't mean it's always going to be a condition, but typically you don't want to just do a blind update, right? You'd probably want to have a condition to make sure we're only updating specific rows and columns based on what we're needing to do. And delete, same thing, right? We're going to delete from a table where condition. So maybe you would have delete from the table being users where user has not logged in for a certain amount of time, right? So you could have like if a property is called logged in is greater than 90 days. Why would you do that? I don't know. That would be a valid condition, right? Or maybe you have users who haven't paid for the past month for a subscription. You give them some grace period, but you're running a query every day to say, well, if this user hasn't paid up in the past 30 days, we want to disable their account. You could have that. Okay. So let's look at create. All right, let me actually jump back into here. So I'm actually going to jump back into the select to show you an example. Okay. So looking here, we could do, let's query something from last name. Okay. So let's do select last name from actor. Okay. Now we actually have, we only return the last names. Why would you do this? I don't know, right? But you could. Or we could do select star from actor where last name, let me actually, it's not just last name, it is a SQL check with string. Yeah. Trying to remember how to do this. Let's try where this might be what I want. Yeah, I'll have to. Oh, it's length. Sorry, I'm thinking of. Yeah. Okay. So that might be a condition, right? Where you want a query where you're only getting strings where a certain value is longer than 10 characters, right? So in that table, we only have 6 users or 6 actors where a last name is longer than 10 characters. Okay. You could have where actor ID is greater than 10, right? Um, you could do where actor ID, I think this should work. Uh, no, that one's not gonna work. But you could figure out like whether the ID is even or odd. Okay. So I just kind of want to show you a few examples. Even this table that we had now, you can narrow down some things that you want, right? Okay. So let's go back to create and we'll get into what the creating looks like. So creating, we have to add data to a database, right? So you have a database for a social media platform, someone signs up for an account. Well, how do you know that they are a valid user? Well, you have to add them to your database. So you may not be thinking about that, right? But if you were to go to Facebook and you had to create a new account, somewhere there is a SQL query saying, okay, now I want to insert this user, right? You have generated a new ID, username, password, all this stuff. And a query similar to this is happening, right? So we see an insert to statement. We're specifying the name of the table where we want to insert that data. And then we are specifying the data that should be inserted. Okay. So we look at this example, insert into employees table, right? And we're specifying what values we're adding. There's an employee ID, a first name, a last name, and a hire date, right? This right here is an interface. We are specifying that it has to be these things and it's going to be these values. Okay. So within a database, you may actually have certain types specified, right? This should be an integer. This should be a string. This should be a string. And this should be a string. So you can run into issues where if you're trying to add a string into an integer field or an integer into a string field. Okay. So that's where that, when I was talking about interface earlier, that's where it's so important to understand that that one-to-one isn't just between tables, but it's also going to be between types. So PostgreSQL database example with types. I really wish I had my existing table to show you. I had a application I made a while back. But you see here in these tables, right? Order ID is an integer, right? Order date is a date, and customer ID is an integer. So when these values are being tied together, it has to be an integer to integer, integer to integer. It's not going to do that type conversion for you. Okay. So that's why we're specifying here where, like which column the value should go and which type it should go. And if your database is set up correctly, again, if you were to add a string into an integer, it would not work and you would get an error for that. So let's look at this example, okay? So we want to add a new actor to the existing actor table. Here's how we can use that to do this, okay? So we want to make a new actress named Emma Boulder. I remember this example from last time. So let's do this create operation, okay? So let's do insert into, and we want to do actor. And we want to specify first name, last update, okay? I can hit enter, right? Because I haven't done a semicolon, so the query is still running. So I'm saying values. I'm going to do Emma Boulder. And when I do now parentheses, I'm creating a new date with this timestamp. Okay. So now we see 0 and 1. Okay. What that means is we have successfully created this entry. So now, if I go to select from actor, and I'm going to write a more specific query. I'm going to say where last name is folder, or is it equals? See, that's where I get confused between Azure and the let's just select down. I think there's, yep. So we see right here 201 Emma Boulder in 2024. Okay, so if you did that, you should be able to see that as well. Let me see if I can write a different query here where last updated is greater than last update. Yep, last update. Yeah, we'll do that on the select later. But let's actually try to do an insert where we make an error. Okay, so I can say insert into actor. We'll do 1, 2 today, or sorry, I have to do the column names. First name, last update, values 1, 2 today. Okay, so here, even though it may not seem like a big deal, it's throwing an error, right? And we'll get into that a little bit more, but it's really important, again, that we are setting this in a way where all of these are actually being with the correct types. Because I could go back in here, I can make a new actor, someone else, right? And it's still going to insert because I did the correct types. Okay. Was anyone able to, I guess, did anyone run into any errors creating an actor into that table? Were you able to successfully find it? Let's see. Check out. The records are case sensitive. Okay. So let me look here. Last name. Okay, good job. Yeah, I'm gonna try this one more time. So select star from actor where okay. Last update greater than 20230101. There we go. Okay. What did I maybe it was the actor where I was throwing that off. Or the only other thing I can think of is let's play that. Yeah, so it looks like I don't think we had specified that there. Let me check double quotes. So it looks like in whatever schema or database we're using, it's the double quotes that was throwing it off. So it actually wasn't the query itself, it's the fact that in here, the double quotes aren't working. So looking here, I pulled something up here on the side. So like for standard SQL, single quotes are used for string literals, and then double quotes are used for identifiers such as column names or table names, which actually makes sense, right? Because here it's saying column 2023-0101 does not exist. So let's try that where we insert this here, right? So it said that column today does not exist. Okay. So it looks like at least with this table, it's not as strict with the types, which is good for this instance, because it does actually show that 1, 2, and here, right? But again, it just all depends on what you are creating with like how that table is set up, which I don't have access to see that. But so at least for today and moving forward, let's make sure that we're using our single quotes. Double quotes are just habit from JavaScript. But at least here we're seeing that not only that, but apparently you can do a string of today and it generates a time for today that is at midnight, which is really interesting. So let's go up here and I'll say tomorrow. And it does tomorrow. That's interesting. I'm learning something. Okay, let's just do them sharks. Okay. That doesn't work because it's not a valid timestamp. So at least we know that. That's good. Cool. All right, so it looks like no one had any errors outside of me, which is great, but at least we're learning something here. Again, the SQL syntax and interfacing that I use in Azure, they don't care about double quotes or single quotes. So that's where, again, it just depends on which database management system you're using. Okay. So let's look at read. We've already been spending some time here, right? But this is going to honestly be what you're utilizing the most. Because 9 times out of 10, what's happening is you have a database, your user has some kind of interaction, you need to access that database to read information, and then you want to display that information on the page, okay? So think about eBay, for example, right? So let's go to eBay. Open up our network tab. Okay. Let's see what pops up. So it's not actually giving me the things that I thought it would get, which is interesting. So let me think of a different website where we may see. Let's go to Google Reddit. Okay. So GraphQL maybe. I was hoping we could find the API call to populate all the different posts. Because in essence, that's what's happening here, right? Is we are logging into Reddit. It's going to make a SQL query to a database, and it's going to retrieve posts from each subreddit, right? And then it's going to display that information. So if you think about that API request that we've had for like the Star Wars, Pokemon, whatever, you have that response, and based on that response, now it's going to render, right? But when you query that API, it's not just stored in the ether, right? It's not just floating around, it's a database. That API request is going to a database with that request, which then gets converted into a SQL query or whatever kind of query. And then it returns that data to your front end framework and it displays the data. Okay. So that's what's happening when we make that API request, and that's what's happening here. So your basic read operation, we're using the select statement. We specify the columns that we want to retrieve data from. We say the data or the table, right? Because maybe there's 10 different tables in that database. Maybe there's just one. But either way, we have to specify the table we want the data from. Because there may be multiple datas or multiple tables with the same column. Remember, you have like employee ID, you may have a movie ID, right? So we have to specify the table we want it from. And then we also have our where clause. And this is where we can filter based on specific criteria, as I demonstrated before, right? Where maybe we want actors with a last name that starts with N. We want actors where they've been in 50 movies, right? We can have that where clause to specify what we want. So in this example, we would say we want the first and last name of employees from the employees table where their department is sales. Okay. So let's look at this example. So going back to our previous database, we want to do select star. So we want all the columns from the actor table where actor ID equals 15. And if we run that, we should see Cuba, Olivier, yeah. And again, last update was 2006, February 15th, right? So let's take a couple minutes. I think we've already seen this a few times. I want you all to kind of come up with your own query. Think of something that might be interesting to try. Use Google to look into how to do it, right? So it's 6 after now. Let's come back at 10 after, and I want to see what kind of queries you all came up with and what kind of data you were able to get. Don't overcomplicate it, just come up with something, right? And again, if you're not sure of how to do that, you could say how to write conditional for SQL query, and you can add conditional logic, right? So there's plenty of examples out here how to do that. If you feel like you need to use ChatGPT for something like this, that's a good use case for that. Okay. So let's come back at 10 after, and when you have it, let's post something in the chat. Okay. All right, give me 1 second. I'm trying something out here. Okay, sorry, I did not realize I was on mute. Awesome. Okay, what did we end up coming up with? Anyone have any queries that they want to share? Even if it didn't work, right? Maybe you had an idea. We can figure out how to do that together. So what do we have that we want to share, and then we'll move on. I'll show you what I came up with. As what I was trying to do earlier, I was just a little off. I'm confusing my JavaScript with SQL. And again, like this is an instance where I was like, Chat GPT, like I know what I want to do. What am I missing? Something like that can be a good tool, right? Not obviously to do the work for you, but to try to troubleshoot where you're going wrong. So what I did is I was trying to figure out IDs being equal or even, right? So I did select star from, I need to do from actor, where actor ID divisible modulo 2 equals 0. And I was doing the equal. That was my fault. I forget. And SQL is just a single equal sign. So now I have all of the actors where their actor ID is even, right? Or I could change that to not, or I could change that to, oh no, I have to go back and forward again. Let's try that again. Hit there. Oh my word. Oh my word. Sometimes my keyboard, it's one of those mechanical ones. I need to slow down a little bit. From actor, where actor ID modulo 2 is not equal to 0, right? So now we have 1, 3, 5, 7, 9, etc. Okay, Omar. So where first name like A or last name like B. Um, Interesting. Okay. Um, I'm not familiar with the like. So what does that do? Okay. So the like operator is used in a where clause to search for a specified pattern in a column. Percent sign represents 0, 1, or multiple characters. Okay. Interesting. Name starts with an A or surname starts with a B. Interesting. I like that. Yeah, I don't know why you need to use that either, but that's kind of the whole thing that we're doing right now. Right. So Joseph, you're saying select star from actor where actor ID between 20 and 100. Okay, so let's look at that. So SQL integer find between two numbers. Okay. So let's look here. So select star from products where price between 10 and 20. Okay. So let's see what happens when we type that. So select star from actor where actor ID between 20 and 100. Can you show me where that didn't work for you, Joseph? I mean, that's where I was looking at your query and I'm like, it looks like it should work. Oh, it's probably because earlier you would have had that queue, right? And it didn't end the query. So that's what we're talking about before, where if you're in the middle of something and you're like, I need to start over and you hit enter, well, the query is not over, right? So you can just hit a semicolon, enter, just clear it out, right? And then you can start again. So I was like, yeah, that query looks solid. So, okay. Does anyone else have anything that they were trying to work with and it didn't work, or something you're like, man, I can't make this happen? If not, totally fine. But again, I'm trying to open this time up so we can experiment a little bit, get more hands-on, because this is going to be important in the next few lessons. And if not, we'll just keep on trucking. Awesome. Okay. So let's go to update. So I want to hear from you. We can see here where we may use an update, but from your end, think about your day-to-day web interaction. Where would you imagine this update querying happening in your day-to-day? Whether it's with correlation one, working at Amazon, maybe you're playing Pokemon Go, right? What do you see being your, like, where updating may be happening? My eBay order status. Yes, right? So you order something and the seller generates uh, a shipping label, right? So once that label's generated, it's updated to the database to say it's been generated, and now it's marked as quote unquote shipped. Little misleading, in my opinion, but it seems like everyone does that, right? So at that point, it that person hopefully packages it up, takes it to the courier soon, right? Oh, and Amazon, yeah, of course, we don't order from our competitors. But thinking about a shipping situation, right? So once it goes to the courier and they actually process it, then now a query is being made to update to whether, for us it'd be the US Postal Service, right? But yeah, it's just this chain reaction of things being updated. Joseph said updating the email associated with your C1 account. Hopefully you're not doing that on a day-to-day basis, but yeah, that would be it, right? Is you update your email, a query is made to a database to say, hey, Joseph's email has changed. As long as the query is correct, then the database is updated. Perfect. So what that SQL query is going to look like for us is update, which is the statement, and we say the table we want to update. We're specifying the values for the columns we want to modify, right? So now we're going to say, hey, anyone in sales, their salary is now going to be 60,000. And we want to specify it's only for sales departments, or the department where it equals sales, right? The where is optional, but it's important because, well, what if you accidentally updated all employees to be 60,000? That might not be good for the people who are only making 30,000. Well, it'd be good for them. You're probably going to get fired. But it's really not going to be good for the people who make 120,000, right? And all of a sudden now their salary's been cut in half. Definitely not great. So that where is not required, but it can lead to a lot of unintended side effects based on what you're updating. Omar says, been there, done that. I would be really curious to hear what that means if you have the time, and I feel like you can share, right? So let's look at this example. So remember that Emma boulder that we made? Well, if you didn't make it, you're going to need to make it now, right? So we want to update our actor table, and we want to set first name being, Tom, last name being thanks. I love this. Last update, we're going to set to now, right? And we only want to update it where first name equals Emma and last name equals Boulder. Oops, what did I do? Right, so we have to look here. Something here got messed up, and it's because I didn't add commas, right? So those are going to be really important. So let's go ahead and update that. So in our set, right, we have to make sure we're adding those commas. That's going to be really important. Okay. I hit enter now. It shows that we've updated 1. So now I should be able to do select star from actor where actor ID equals 201. And I now see Tom thanks. Okay. Now, let's say I didn't have that where clause, right? I'm going to do something very foolish. And I'm going to go in here. I just updated 204 entries. So select star from actor. I now have a lot of Tom thanks, right? Oh, I'm not sharing my screen. It says sharing screen, right?
Yeah, you're sharing the screen.
Okay. Yeah, Sarah gave me a heart attack there. So as you can see here, I now have multiple Tom thanks, right? That where clause is really important. We cannot not include it when it's something like this, right? So it says optional because you can still run that query, but that optional only means that if you don't include it, the query still runs, right? But it's not optional in the sense of your database is going to be able to read your mind. So please, 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 please double check your query before you run it. Omar just shared this. He said updated table with almost 8,000 records without signing a where clause. It contained financial data, and I basically single-handedly demolished the financial department for about 18 hours before the database admin could successfully recover it from the transactional logs. Yes. Don't be Omar, right? Because I mean, I'm glad you shared that because that happens a lot. Unfortunately, it's not as uncommon as you think, which is where you can I'm trying to remember. Let's see. SQL query. So you can do this, which is very helpful. And I wish I would have remembered this when I just ran that last query. But you can add begin transactions. So you execute your script, right? Before you do it, you add begin transaction. And after you execute your script and you've done your checking, you can roll back, right? So this allows you to be able to undo your changes. I've had to do that in the past just because I wasn't super familiar with SQL. And really, when you're doing a mass update, it's always good to have that check in place. To Omar's situation, a database admin can go in, and as long as you have commit history, you can always update it, right? Uh, Unfortunately, not everyone's going to have that, but it sounds like you learned from it, right? And that's the important thing. Sounds like it wasn't permanent, but unfortunately, there are just going to be times where that's not the case. It's again, the where, it's only optional. I cannot understate this enough. It's only optional that you can leave it off and still run your query, but it's not optional in the sense of specifying the data you want to update. Okay. What questions do we have before we move on to delete? If we're good, just throw a thumbs up or something in the chat so I know, and we'll move on to the next section. Hey, Joseph's doing well. Looks like Timo's typing. While you're typing, actually. Uh, Sorry, could you show again how you corrected the forgotten comma without rewriting everything? Yeah, absolutely. So really, it's just what I'm doing, just like with our terminal commands, you can press up and you can pull up previous commands in that session. So I just pressed up and I just went left, right? If you press up again, it's going to do that previous command, right? So you can't press up to go up a line. So think about it if I was just to write a regular SQL query without it being on multiple lines, right? So select, let's just do update actor set first name equals Hillary, and I'll leave the comma off. Last name equals Shark. Last update yesterday. Okay. When I hit the semicolon, I can just hit left, right? And then I'll do comma, but you have to remember, at least in this terminal, where you're highlighted, it's before that highlight, right? So I'll hit comma there, hit enter. So it doesn't look like there's a yesterday, so we could just do today. And actually, it's not going, oh, I need an equal sign. There we go. Cool. So now, like I said, I went left and right to move around in my command. I'll do select star from actor, and now we have Hillary Sharp. Okay. Does that answer your question, Tima? So again, you can press up and down to go through any previous queries or commands in our terminal, as long as it's that session. And that's any terminal that you're using, okay? Whether you're using JavaScript, Python, etc. All right. So now delete, right? So delete operations in a database involve removing existing records from a table. So this would be whether the data is no longer needed, it's no longer relevant, user asks us to remove them from their emailing list, right? That would be a way where you'd want to delete, right? Or maybe in that instance, we don't want to delete their data because maybe they'll change their mind. You could set it to be like should email and you update that value. Now, again, that's where that legal, ethical grayness comes in. It's not a conversation for today, but let's just imagine that we just need to delete the user, right? So this query here, we're seeing delete from employees where department equals marketing. So apparently our marketing department's closing down. We're deleting everyone, okay? So now, to understand again, we may need to free up data. We need to remove no longer needed information, but it's important to use this carefully, okay? So I'm going to pull this over to the side really quick. I'm going to look something up. I want to do that begin transaction thing we're talking about. We'll find this in Google again. Okay. So let's say we want to no longer have Hillary Shark in our database, right? Because again, I don't have Tom Thanks anymore. So you probably have Tom Thanks. So let's try this out. Okay. So again, it's not here, but we want to test this before it happens. So let's do begin transaction. Okay. Semicolon. If you did it successfully, you should see begin here. Okay. So let's say I forgot that I updated everyone to Hillary Sharp. Okay. So let's say I do delete from actor where first name equals Hillary and last name equals Sharp. Okay. Won't let me do that, right? Okay. So where first name equals, I think maybe it's because there's so many. So let's try this really quick. Oh, I see. Okay, so I'm going to add a new actor actually. So let's do insert. What was we're going to go back into create. So there's another table where one of those actors is actually being referenced, so I'm not going to be able to do that. So let's do insert into actor, first name, last name, update, values, thanks. Now. Okay. So we are going to do the same example now. Okay, so let's go back and say begin transaction. Okay. So delete from actor where first name equals Tom and last name equals thanks. Okay. So we see here it says delete one, right? Which is good. You know, that means it successfully was deleted. But let's say we decide, you know, actually, let's say it deleted more than we wanted, right? Or we ran that, or like, actually, no, I don't want that to be the case. So I could check to make sure it worked by saying select star from actor where last name equals thanks, right? So we can see here it was successfully removed. But if I change my mind, I can actually go roll back. And anything that happened in that transaction is no longer finalized. It hasn't been committed. So I could go back and run my query, and we see that he wasn't actually deleted, right? Because I did not commit to that deletion. In the same way, let's start that transaction. And I could do that update that I ran before, right? So let's go back here to update. Begin transaction. And I'm going to copy this query, right? Where now I want all of my actors to be Tom Thanks, right? Like we had before. So select star from actor. So we see everyone's Tom Thanks. But I decide, again, I don't want to do that. I'm going to roll it back, right? So we're back to Hillary Shark. Okay. And what's really interesting, actually, if you notice, it deleted all of them up to 58 because apparently 58 has a tie to a different table. So it did actually work, that deletion, just didn't work the way we thought it would. Okay. So let's actually commit that change. So we'll do begin transaction again. And we'll do delete from actor where first name equals Tom and last name equals thanks. Okay, so we ran the query, we saw it was successful, we want to confirm that it worked. Select star from actor where last name equals thanks. We see that it worked as expected, and now we can actually say commit. And now, if I run that same query, we see that those changes were actually committed. Okay, so that transaction process here, I would argue, is really important when we're making big changes, right? Changes that would be hard to undo easily, because we can test to make sure that it's working as expected. And as long as we're happy with the results, we can commit it. Otherwise, if we're like, oh no, actually, that wasn't what I wanted my query to be, then you can just roll it back. And that gives you a little bit of flexibility too, because instead of creating like a test database, you can try out different queries. And as long as you do that begin transaction, it's not permanent, right? So at that point, you could roll back or you could commit to make it permanent. Okay. So again, we see here, we began that transaction, we deleted the actor of Tom Thanks, and we committed that change. Okay. So we're about to go to break. What questions do we have about our CRUD operations here in SQL? Okay. If we don't have any questions, if we're feeling good, it is 37 after, so let's come back at 48 after, and then we will start working on the lab for the rest of the session, okay?
I found a way to mute that thing, so
Awesome. All right, can you let us know in the chat that you're back before we get started? Let's throw a GIF or something on. We did good job last time. Let's make sure you're alive in there. Yeah, emoji works too. All right, Tatiana's back. Omar, Abbas, Dragos, perfect. All right. So we actually have two labs today that you're going to be working on, and both of them are going to be similar, right? So it's not going to be drastically different, but I'm going to go ahead and cover the main focus of the first one. So my thought is we have 40 minutes. So give everyone till about 15 after to complete these two labs, and then we'll go over it together. Okay? Oh, that's a good gift. Thank you. So that actor table that we have, right? If you didn't do what I did, so select star from actor. Yeah, see, mine's pretty messed up. So I will have to leave and come back to start that over. But what you're going to do, in these labs, you do actually have to submit your code for this. Okay, I want to clarify that. So you're going to have 4 different queries that you're going to be running. So the first one is you're going to need to create a query to retrieve the details of any actors with a first name Kenneth. Second is going to be add an actor named Bruce Wine to that table. You want to change the last name of the actor with the ID 7 to streak. And let's go ahead and remove any actors with the last name Wine from the table. Okay. So once you've done that, add your SQL queries to the space below, separate your answers with numbers, right? So 1, 2, 3, 4, make sure you submit your answer. And then for the next lab, we're going to have a table called country. Okay. So similar, we're going to want to get a list of countries from the country table, but we only want 20 countries. Okay, so you're going to have to add a limit on that. You're going to want to update the entry for the country Turkey to be Turkey. Okay. We also want to add a new entry in the database for South Sudan. And then we want to retrieve a list of countries from the country table, but we're going to sort them in descending order by country name. Okay. You have a little tip here to be able to do that. So once you've done that, same thing, 1 through 4, add your queries, make sure to submit your answer. And then we'll be back at 15 after to review that, and then we will wrap up. Okay. I know I asked this a lot, but what questions do we have before we start working on the lab and then getting back together? Any thoughts, questions, concerns before we start? I'm going to confirm that I can exit, come back in here, preview. Here. Yeah, so if for some reason you get messed up, let us know, but you should still be good. I was able to leave and return and have my table reset. Okay. So 15 after, that gives us about 24 minutes. Okay. Any questions, please drop them in the chat. Veronica and I will be watching.
Hello, everyone. Are we back? Yes, we're back.
All right. Yeah, let's throw something in the chat. Let us know you're back, and then we will review the labs and skedaddle out of here. Awesome. Okay. Is there anyone that was able to finish the labs or who got really close and maybe just like not quite there? Appreciate the honesty. All right, so let's break it down. Oh, Omar, awesome. You managed to finish it. Great, glad to hear it. If you have anything you'd like to share, if any issues you ran into, maybe something you could help encourage your other fellows. Joseph, you finished it. Awesome. So sounds like a few of you were able to complete it. Okay. So let's go through this really quick. We're not really going to do a whole lot outside of what we've already seen, right? And again, that's really the goal is with these labs, we're trying to build off of what you've already seen, and with the projects, trying to build off of previous lessons, okay? So we've already worked with this actor table quite a bit. So for query 1, we want to retrieve the details of the actors with the first name Kenneth. So this would be a read, right? So we do select. And since it didn't specify specific details, we just want the details, that's where we'd want to add the asterisk, okay? So we know it's from the actor table, so we'll do select star from actor, where first underscore name equals Kenneth. Oops, and we need to have single quote. Okay. Well, didn't have anything there, and I wonder why. Let's try something else. It's case sensitive. Okay, so we have to make sure we're paying attention to the case of our query, right? So there's ways that we can sanitize that a little bit more to open it up, but what we're looking for specifically here is Kenneth in all capital letters, okay? So our query is select star from actor where first underscore name equals Kenneth. All right, so now we want to add a new actor, okay? So if you don't remember how to do that, and that's okay, what I would suggest doing, so you're not going back and forth, is you can duplicate your tab, okay? I mean, I have to do this. I don't have these SQL queries memorized, but I know where to go, right? So we can go to create. Okay, so remember we insert into, and then we add our values, okay? So let's do insert into. And let's do, again, we see actors, the table. So we have first name, last update, right? And we don't have to add an ID because it actually will create, some of these tables will create those IDs for us. So we don't have to worry about that here. And now I want values, right? So I'll do Bruce, I'll do all capitalized. Oops. Bruce wine, and we'll do now, right? Don't forget the semicolon. So I should be able to hit select star from actor where last name equals wine. And I see that I added Bruce Wine. Okay. So now what we want to do is change the last name of the actor with the ID 7 to street. So we can look here at update, right? So let's do update actor, right? So we want to target this table. And we can say what we want to set. Okay. So set last name equals street, where actor ID equals 7. So we see here successfully updated 1. We can do select star from actor where actor ID equals 7. And we see Grace Street. So we successfully did that. And last, we want to remove any actors with the last name of wine. So let's do our begin transaction. You don't have to do this, but I want to make sure it's working, right? So now I look at my delete. So delete from table where condition. Okay, so delete from, right? It's not just delete, delete from actor where last name equals wine. And it shows that shouldn't we also update the last update? Yes, you should, right? I'm not gonna argue against that, but you see here, the last update actually is being updated, right? So I didn't want to get too into that, but technically when we do update, I'll show you, it'll actually update automatically. Okay, so it does show here that we did delete that user, right? So I feel good about that. Now I'm going to say commit. So if I did select star from actor where last name equals wine, it should return 0. Okay. So what I'll show you here, to Omar's point, select star from actor where actor ID equals 2. All right, so we have Nick Wahlberg. Okay. So now I want to update. Let's do update actor, set last name to street where actor ID equals 2. Okay. So now if I do that, we'll see that it actually automatically updated. And that's something where you have to set that up in the database. I didn't really want to get too deep into that. So it's always good if you don't have that in place. Like we wanted to show you that now method, right? Where it would automatically add that date. But 9 times out of 10, and I know I use that phrase a lot, but really majority of the time when you have a database with an updated value or, property, so to speak, there'll be something in the database structure, the schema, to say if this is ever updated, it'll update at that time, right? And the reason for that is, let's say you have people working in the United States and Europe and India and Australia. Not only will it automatically update when that change is made, but it's going to update based on the database server time rather based on the relative time, right? Because all of those places are in different time zones. So it'll update based on a time zone established, which is usually, I think it's UTC is the acronym. Okay. So let's go to lab number 2. Okay. And again, remember, make sure you're doing 1, add your query, 2, 3, 4, and submitting your answer. So with the countries database we have, so let's do select star from, and what's the table name? Country, right? And if you forgot how to limit, you could just go back here to select. We have this as an option here, right? Limit. And we'll do limit 20. So now we see we only have the first 20. Okay, so that's our first query. Now, if we want to update, we can do update and in that table. So update country, right? And then we want to set the column and value. So we'll set country equals per height, where country equals Turkey. Okay. So that, let's see here. So now if we do select star from country where country equals what? Let's see here. This working earlier. I'm going to come back to this one here in a second. I'm curious to see what query you had. I'm missing something that I did prior to this. Let's look here. Actually, that's solution number 2. Update country set. Yeah, that's.
Maybe double quotes.
Oh, there we go. There we go. All right, so let's go back up there. Great catch. So, all right. Why? So it's still won't let me exit. All right, I'm going to. How do I clear out of here? Yeah, I see that. So I'm just going to refresh really quick. Yeah, those double quotes will get you. All right. It's like, I know I'm doing this right. Okay, so we'll go back into here. Let's do that again. So update country, set, go back into here. So country equals, well, where country equals Turkey. There we go. So now if I was to select star from country, where country equals, we should see that it updated successfully. Okay. And something to be mindful of is when you're creating your databases, it's not a bad idea to have a different column name compared to the actual table, because it can get a little confusing. Select star from country where country equals that, right? Again, you can decide how you want to do it, but just be mindful of you're in charge of that if you're creating it. So don't over confuse yourself. So now we want to create a new entry into the database, right? So let's look at our create. So insert into table, column names, values, what we want. Okay. So insert into country. And then we need to have the parentheses. So we'll do country, where, or sorry, values. And then we'll do South Sudan. Okay. So now if I do select star from country, where country equals South Sudan, I should see ID 110, and we updated it here. Okay. Now, last, we want to retrieve a list of countries from the country table, sorting them in descending order. So if you weren't sure how to do this, just click through here to W3 Schools, right? And this shows you how you can do this. And you have this option here of ascend, ASC, or descend, DESC. Okay. So let's do select star from country, right? And then we see here order by. And we want to order by country, and we want to do descending. Okay. So now we're starting with the idea of 109, and it's going all the way down to, well, to the end of our our table, okay? So it goes from 109 down to 1. Okay. And that's it. So you should have been able to add those queries into each text submission box. Make sure to submit your answer. And then here at the end, you want to mark this as completed as well. Veronica's not going to be able to effectively grade your assignment without that marked as completed. So with today's lesson, we learned about relational databases, right? We did talk about non-relational a little bit, but our focus is going to be on relational. We talked about some basic SQL commands such as select, update, delete, and insert. This was added on there. It did get removed, so I apologize that that was not covered or not removed from the recap. So don't feel crazy if you're like, we didn't go over SQL injection. So really the main thing we wanted to understand today is how do we update, add, delete, and read data from a database, excuse me, and be able to effectively create SQL queries. So next week, what we're going to do is we're going to talk about Supabase, which is a database management tool. And we're going to actually integrate that with React and start utilizing React to communicate to a database to perform these CRUD operations. So I don't have anything else to share. Juan, Veronica, do you have